In this problem, you were given an angle that is inside the circle and you were looking for one of the arcs. You will use the formula angle equals arc plus arc over 2. You were given the angle measure, so you get 70 degrees equals one of the arcs, which is 55, plus the other arc, which is x, over 2. From there, you will solve the equation by multiplying both sides by 2, and you get 140 equals 55 plus x. And then to solve for x, you subtract 55 from both sides to get x equals 85. In this problem, you have an inscribed quadrilateral, which means all the vertices touch the circle. The property for this is that opposite angles are supplementary, so you've got to create two separate equations. 2x plus 100 is going to equal 180 because those two angles are supplementary. And then you have y plus 86 equals 180 because those are supplementary. From there, you will solve for x and then solve for y. In this problem, you are told that AB is tangent to the circle. We know a tangent line is perpendicular to the radius, meaning we've created a right triangle. In order to solve for a missing side in a right triangle, you use the Pythagorean theorem. The longest side, or the side across from the right angle, has to be the hypotenuse. Therefore, 12 is our hypotenuse. So we get 7 squared plus r, which stands for the radius, squared, equals 12 squared. And from there, you can solve for the radius. In this problem, you were given two different types of angles in the circle. We have a central angle, which is angle AQC, and we have an inscribed angle, which is angle ABC. The first thing you have to use is the property of central angles. We know that AQC is also going to be congruent to arc AC. Therefore, AC is equal to 2x plus 6. Then we can use our other angle, which is angle ABC, and it is an inscribed angle. So it equals the arc over 2. So we get 54 degrees equals 2x plus 6 over 2. And then you have to solve for x by multiplying both sides by 2. So you get 108 equals 2x plus 6. Subtract 6 from both sides, and you're left with 102 equals 2x. And then you've got to divide both sides by 2 to get x by itself. In this problem, it tells you that you have two tangent lines that meet at an external point. It also asks you to find their congruent length. So in the problem, it tells you exactly what you need to do. Congruent means equal to, so you need to set the lengths equal to each other and solve for x. You get x equals 4, but the problem does not ask us to find x, so we have to go back and substitute that in to the length to answer the question. So we plug 4 back in for 6x plus 5, and we get the length to be 29. In this problem, you were given one arc measure, and you were asked to find angle BDC. Angle BDC is an inscribed angle, and it goes with arc BC. So in order for us to use the formula arc equals angle over 2, you have to first find arc BC. Arc BC plus CD equals 180. Arc CD is 64 degrees, that's given in the problem. So we can find BC by doing 180 minus 64, and arc BC equals 116 degrees. So in order to find the angle, we do 116 over 2 to get 58 degrees. In this problem, you were given an inscribed isosceles triangle, meaning that side AB is congruent to side BC. AB and BC are chords of the circle, therefore arc AB is congruent to arc BC. We are told that arc AB is 108 degrees, so arc BC is also 108 degrees. We want to find the inscribed angle, angle ABC. Angle ABC goes with arc AC, so we must find AC first. We know that all three arcs add up to 360. So we're going to do 108 plus 108, and subtract that from 360 degrees. We get arc AC to be 144 degrees, and we are going to divide that by 2 to get angle ABC to equal 72 degrees. In this problem, you were told that QT is tangent to the circle. We know from the problem earlier that a tangent line is perpendicular to a radius. Therefore, angle T is 90 degrees. We are also told in this problem that arc ST is 70 degrees. Arc ST is congruent to angle P because angle P is a central angle. Therefore, angle P is 70 degrees. We know two angle measures in this triangle, so we can find the third. The triangle sum is 180 degrees. So angle P plus angle T plus angle Q is equal to 180 degrees. So now you can substitute in the measures for angle P and angle T and solve your equation for angle Q. You get angle Q to equal 20 degrees. In this problem, you were asked to find surface area. You were given that the radius is 8 centimeters. The surface area is 4 pi radius squared for a sphere. This formula is given to you on your formula sheet, so all you need to do is plug in the radius. This problem asks you to find out how much the volume is going to increase if the radius is increased 3 times. This goes back to Unit 1 when we did dilations in scale factor. Our scale factor here will be 3. When we deal with volume, we cube the scale factor, so this actually gets 27 times larger than the smaller ball. This problem asks us to find the volume of the two figures. The volume formula for a sphere and for a cylinder are given to you on your formula sheet. The volume for a sphere is 4/3 pi r cubed. In this problem, the radius of the sphere is 2, so we substitute 2 in for the radius, and we can put the rest into our calculator. Don't forget to use your fraction button for 4/3. Then for the cylinder, the formula that is given to us is big B times h. Big B is the area of the base. The base of a cylinder is a circle, so you need to use pi r squared to find big B and then multiply that by the height. This problem gives us that the diameter of the base is 10. So you first need to find the radius, which will be 5. So you get pi 5 squared, which is the area of the base, or big B, and then we multiply it by 12, which is the height. This problem is asking us to find central arcs. We know that central arcs are congruent to central angles. The first problem, yes, we have a typo on here. It says to find arc AB, but the actual problem wants us to find arc MN. Arc MN is created from the central angle whose measure is 70 degrees. So MN is 70 degrees. Then it asks us to find arc QNR. We know that QNR plus arc QR totals up to 360 degrees. We have vertical angles on here, so angle QOR is also 70 degrees, meaning arc QR is 70 degrees. So we can do 360, which is the total of a circle, minus arc QR to get arc QNR, which is 290 degrees. From there, we are asked to find MR. We know that arc MR and arc MN create a semicircle, which is 180 degrees. So we do 180 minus 70 to get arc MR, which will be 110 degrees. And then the last one asks us to find arc PRN. Arc PRN is made up of PN, NM, and MR. We know what each of those arcs are, so we can use arc addition postulate and add all three of them up, and we get arc PRN to be 260 degrees. We are asked to find angle GHJ. The vertex of this angle is on the circle, therefore we have an inscribed angle. The inscribed angle formula is angle equals arc over 2. The arc that is created from angle GHJ is arc GJ. It is 100 degrees. So we divide 100 degrees by 2 to get our angle, which is 50 degrees. This problem asks us to find arc CD. We are given an angle measure. We are given angle CBD. CBD has a vertex that is on the circle, so it is an inscribed angle, meaning we need to use the formula angle equals arc over 2. Our angle is 40 degrees, and we don't know what our arc is. So we get 40 degrees equals arc CD over 2. We are solving for CD. So we multiply both sides by 2 to get CD by itself. 2 times 40 gives us 80 degrees. So arc CD is 80 degrees. We are asked to find angle C. We know angle C is an inscribed angle, so we may need to use that formula. But let's look at what we're given first. We know that CB is a chord that goes through the center of the circle. Therefore, CB is a diameter, meaning that arc CB is 180 degrees. Since arc CB is 180 degrees, that means that angle A is 90 degrees, because it is an inscribed angle that creates the other semicircle of this circle. If we look at this picture, we have a right triangle whose hypotenuse is the diameter, because angle A is 90 degrees. We know two angles in this triangle, therefore we can find the third using the triangle sum theorem. Angle C plus angle A plus angle B equals 180 degrees. So we fill in the two angle measures that we know so that we can solve for the third. Angle C plus 90 degrees plus 50 degrees equals 180. Then we add the like terms and we get angle C plus 140 degrees equals 180. We subtract 140 from both sides because we are solving for angle C. So we get 40 degrees. We are asked in this problem to find angle 1 and angle 2. Looking at these two angles, we can see that they are supplementary. We need to find one of them first. We are also given two arcs. These two arcs are formed from angle 1, so that is where we need to start. We want to find angle 1 first. Angle 1 has a vertex that is inside the circle. Therefore, we will use the formula that goes with that. That is, angle equals arc plus arc over 2, or the average of the arcs. So angle 1 equals 33 plus 131 degrees over 2. When you put that into the calculator, you get 82 degrees. Now that we know that angle 1 is 82 degrees, we've already decided that angle 1 and angle 2 are supplementary. That means we can create ourselves an equation based on the definition of supplementary. Angle 1 plus angle 2 equals 180 degrees. We can substitute in the measure for angle 1, so we get 82 degrees plus angle 2 equals 180. We subtract 82 degrees from both sides so that we can solve for angle 2. Angle 2 equals 98 degrees. This problem asks us to find x. X is an arc. This arc goes with an angle that is inside the circle. Therefore, we need to use the angle inside a circle formula, which is going to be angle equals arc plus arc over 2. When we do this, we get angle, which we don't know, equals 144 plus x over 2. So before we can solve for x, we need to find what that inside angle is that goes with these two arcs. We are given an angle inside the circle. It is 52 degrees. The one that we need to be able to use our formula is supplementary to 52 degrees. So we can set ourselves up an equation to find the angle we need. We're going to do 180 minus 52, and we get 126. So this is the angle that goes with the two arcs. So we can go back to the formula that we decided we needed to use, and we're going to substitute in the values where they go. We know the angle, so we get 128 equals 144 plus x over 2. We multiply both sides by 2 because we're trying to get x by itself. We get 256 equals 144 plus x. We then need to subtract 144 from both sides, and we get x to equal 112. This is a two-part problem using the same properties that we've done in previous problems. We need to first find arc 1. Arc 1 goes with an angle whose vertex is inside the circle. So we need to use the formula angle equals arc plus arc over 2. The angle is 70 degrees, one of the arcs is 66 degrees, and one of the arcs is arc 1, which we don't know. So to set up our equation, we get 70 equals the arc, which is 66, plus our other arc, which is arc 1, divided by 2. We are solving for arc 1, so we need to get that by itself in our equation. So we multiply both sides by 2. We get 140 equals 66 plus arc 1. Then we subtract 66 from both sides, and we get arc 1 to equal 74 degrees. Then we need to move on and find arc 2. Arc 2 goes with an angle whose vertex is inside the circle. We don't know what that angle is, so we're going to have to find it first. The angle that goes with arc 2 is supplementary to 70 degrees. We will find that angle first by doing 180 minus 70 degrees. We get that inside angle to be 110 degrees. We can now use the same formula that we did to find arc 1. We get the angle, which is 110, equals arc 2, which we don't know, plus 126, which is the other arc, over 2. We multiply both sides by 2, and then we get 220 equals arc 2 plus 126. And then we subtract 126 from both sides to get the measure of arc 2, which is 94 degrees. This problem is just like number 11. We need to find arc 1 first. Arc 1 goes with the inside angle, which is 47 degrees, and it uses the arc that is 41 degrees. The vertex of the angle is inside the circle, so we will do angle, which is 47 degrees, equal to arc 1 plus the arc that is 41 degrees divided by 2. So we've set up our equation and we need to solve for arc 1. We multiply both sides by 2 and we get 94 equals arc 1 plus 41. Subtract 41 from both sides and we get arc 1 to equal 53 degrees. To find angle This problem asks us to find angle 1. Angle 1 has a vertex that is outside the circle. It is created from one tangent line at the top and one secant line at the bottom. We can use the outside angle formula, which is angle equals far arc minus near arc divided by 2. Angle 1 will equal 138 degrees minus 66 over 2. You can plug this in the calculator just like this, but make sure you're using the fraction button if you use the yellow calculators or the TI-36 Pro. This problem wants us to find the angle marked 2 and the arc that is marked 1. Let's look at the angle first. That angle has a vertex that is outside the circle. Therefore, we're going to use the formula angle equals far arc minus near arc over 2. 134 degrees represents the measure of our far arc, and arc 1 represents our near arc. We need to find that near arc before we can solve for the angle. Looking at this problem, our circle is split up into 3 arcs. Arc 1, the arc whose measure is 134 degrees, and the arc whose measure is 170. We know that all of the arcs inside of a circle add up to be 360 degrees. So we set ourselves up an equation to find arc 1 first. Arc 1 plus 170 plus 134 equals 360. We combine like terms to get arc 1 plus 304 to equal 360. Then we subtract 304 from both sides and we get arc 1 is 56 degrees. Now we can go back and use the formula that we picked out in the beginning. Angle 2, which is the angle whose vertex is outside the circle, is equal to the far arc, which is 134 degrees, minus the near arc, which we just found to be 56, divided by 2. When you put this into the calculator, it is 39 degrees. Don't forget to use the fraction button or your answer may be a little off. This problem is just like number 14. We have an angle whose vertex is outside the circle and we need to find it. We are going to use the formula angle equals far arc minus near arc over 2. We don't know our near arc, so we must find that first. This circle is split into 4 different arcs, and their sum is equal to 360 degrees. We set ourselves up an equation to find the missing arc first. We get the missing arc, or arc 1, to be 54 degrees, and then we can go back and use our formula to find angle 2. Angle 2 equals the far arc, which is 130 degrees, minus the near arc, which is 54 degrees, divided by 2. we get angle 2 to equal 38 degrees. This problem is a very straightforward problem where you just need to use the area formula. The area formula is given to you on your EOCT formula sheet. The key to this problem is that you first needed to find the radius. We are given a diameter of 22, therefore our radius is 11 inches. Then you can plug that into the area formula. Make sure on the EOCT you are always determining what you were given before plugging it into a formula. This problem asks us to find the area of the shaded region. This is the same as finding the area of a sector. The sector of a circle is a piece of the entire circle. Therefore, we need to find that piece and multiply it by the entire area of the circle. You are not given this formula on your formula sheet. The piece of the sector is represented as the measure of the arc that's formed from the sector divided by the entire circle, which is 360, times the entire area, which is pi r squared. We know that angle Q is a central angle, therefore arc RS is congruent to it. The measure of the arc that is formed from this sector is 106 degrees. So we do 106 divided by 360 times pi times our radius squared, which is 9. When you plug this into the calculator, you get 74.93 feet squared. Area is always measured in units squared. You can plug this in the calculator the exact way I have it on here, as long as you use the fraction button. If you are not using the yellow calculator, the Multiview, or the TI-36 Pro, you will want to plug this in pieces in order to ensure the correct answer. This problem is the same as number 19. You want to find the area of the shaded region. So you will find the arc of the sector. You will divide that by the entire circle, which is 360 degrees, and multiply that by the area. Again, you can plug this in the calculator the exact way I have it on here, as long as you use the fraction button. This problem gives you the circumference of a circle and it asks for the radius. On your formula sheet, you were given that the circumference equals 2 pi r. That is the formula you must use because that's what you're given. When you go to use this formula, you are going to plug 25.12 feet into the left side of your equation because the left side represents circumference. So 25.12 equals 2 pi r. We don't know what r is, and we want to get it by itself. So we divide both sides by 2 pi. 25.12 divided by 2 pi is approximately 4 feet. So your radius is 4. This problem wants us to find the arc length of AB. This tends to get tricky for a lot of students because you're so tempted to put the measure of the arc. We've got to remember that arc length is not the same as arc measure. Arc length is equal to the arc divided by the total measure, which is 360, times circumference. Arc length is a piece of the circumference. So we do arc AB, the measure of arc AB, which is 97 degrees. We divide that by 360 and multiply that by 2 pi times the radius, which is 4. We plug this into the calculator the same way that's on here, as long as we use the fraction button. You should get the arc length to be 6.77 feet. This problem asks us to find the arc length. Again, we've got to remember that arc length is different than arc measure. Arc length is a piece of the circumference. Therefore, you find the piece of your sector and you multiply it by the total circumference of the circle. Our arc measure of arc XY is 60 degrees. So we do 60 degrees divided by 360 times 2 pi times the radius, which is 4. Plug this in the calculator the exact way I have written down. You must use the fraction button. If not, you need to do this in pieces. Do 60 divided by 360 and then multiply that times 2 pi times 4. This is a lengthy problem. It's going to be one that you see on the EOCT. They love to ask these multi-part questions. This tells us that a birthday cake is sliced into 8 equal pieces. It gives us the arc length of one piece of cake, and it wants us to find the diameter. So I know some of you are thinking, what in the world do I do? You first need to figure out what you know, and then what we can figure out from there. We know we're given arc length, so we automatically know we need to write down the formula for arc length. Arc length is equal to the measure of the arc over 360 times 2 pi times my radius. Well, I'm asked to find the diameter. Nowhere in that formula is diameter. But what I do know is that diameter is equal to 2 times the radius. So what I can find from the arc length formula is the radius. If I fill in what I know for my arc length, I'm still missing the measure of the arc. My problem did not tell me what the measure of the arc was. But what it does tell me is that I have 8 equal pieces, meaning that my entire circle is split up into 8 equal pieces. An entire circle is 360 degrees, so we do 360 divided by 8, and we get one of the arc measures to be 45 degrees. Therefore, we now know the arc length, and we know the measure of the arc. We can fill those into our formula to find the radius. Arc length goes on the left side, and that is 6.28, and it equals 45 over 360 times 2 pi r. What I did was divide 45 by 360 in my calculator first, and that gives me 0.125. So what I have on the right side is 0.125 times 2 pi times r. I need to get r by itself, so I need to get rid of everything that is in front of r. All of that stuff is multiplied by r, so I divide both sides by what's in front, which is 0.125 times 2 pi. So 6.28 divided by 0.125 times 2 pi in my calculator is approximately 8. Make sure you are using your fraction button. You get the radius to be approximately 8. But what I've done is I've forgotten to go back and answer the question. My radius is 8, but the problem wants me to find the diameter. So I now need to multiply that by 2 to get my diameter, which should be 16 inches. This problem gives me a clock. It tells me that the entire clock has an area of 452.39 inches squared. I'm asked to find the diameter. Then I want to find the area of the sector, when the time is 3 o'clock. This is a multi-step problem. The first thing I need to do is figure out what I can solve for using the area formula. Area equals pi r squared. Well, I know the total area, therefore I can find the radius. I plug in 452.39 in on the left side for area, and that equals pi r squared. I want to get r by itself, so I divide both sides by pi. I get approximately 144 when I do 452.39 divided by pi. So I have 144 equals r squared. To undo squaring, I need to square root both sides. Therefore, r equals 12. I know my radius is 12, but I want to find the diameter. So I need to multiply that by 2. My diameter equals 24 inches. It then asks me to find the area of the sector. Well, I know from before that the area of the sector is equal to the measure of my arc divided by 360 times the total area of the circle. If you look at when the clock is 3 o'clock, it creates a right angle. A right angle is 90 degrees. Therefore, the arc created from that angle is also 90 degrees. So I do 90, which is the measure of my arc, divided by 360, and I multiply that by the area, which is pi r squared. I know that my radius from before is 12. So when I plug this in my calculator, using my fraction button and using the pi button, I will get 113.1 inches squared. Remember, if your calculator gives you an answer with pi in it, always push the button above enter to convert it to a decimal.